Can everyone hear me?
Yeah.
Okay, we're good. So my paper is loss of oncogenic Notch1 with resistance to a PI3K inhibitor in T-cell leukemia. Or, in simpler terms, if this would work. It's not working. Mutations between parental leukemia and resistant strains. Okay, so special thanks to Mr. D. He's met a lot with me, so thanks to him. Matt Newman, Catherine Mathias, and Mark Strachman, Jackson Hoyt and Jake Robinson, and a special, very special thanks to Jackson Hoyt, who has been my mentor for the past 3 weeks, 4 weeks, I don't know, but he's done a lot for me. And then Claire Putman, Sydney Stein, and Sophia and Jen. So why is this important to me? 2 clicks. Yeah. So my uncle was diagnosed with leukemia in July of 2010, and he had bruising, and he felt very sick, so he went to the hospital, and he was going to leave for a month. So this is really important to me, and this is kind of dedicated to him. He's fine now. He is going to be 5 years cancer-free in next September. Okay, so here's a little background. So the specific type of leukemia, the specific type of leukemia that I'm talking about is T-cell acute lymphoblastic leukemia. So it's a type of leukemia, and what it is premature blood cells, T cells, come into the blood, is kind of the simplest way to put it. And then most patients relapse after treatment, resulting in a successful treatment rate of only 40%. And so for 2014, there was 1,440 predicted deaths in the US alone from TL. So here's some terms to know. So Notch1 regulates signaling between adjacent cells. Is there any questions on that one? Because that's big. Okay. So the RAS or PI3K pathway is part of the is a pathway that involves cell growth, division, and survival. And MEK is part of the same pathway.
Somebody ask a question. One question. Back there.
You said Notch1 regulates signaling. Like, what type of signaling?
Like, it has to do with signaling. So here's an example. So if you were to block Notch1, it should stop the PI3K signaling as well. So it regulates all the signaling that has to do with between adjacent cells.
So Notch1 actually is like in that idea of the cell growth and division and survival. Like that's what Notch1 kind of does when it's signaled.
Yes.
Okay.
Yeah.
Are PI3K and MEK part of the same pathway?
Yeah, as you can see in the
Okay.
picture over there, it's a little blurry, but it's RAS later, it later shows, signals later in the pathway MEK, and then later in the pathway, if you go off a different way, is PI3K. Does that make sense? Okay, so where did they start? So GDC is a PI3K inhibitor. So PI3K, as I said, has to do with cell survival and cell proliferation. So cell proliferation is the division of cells. So they exposed a TL cell line E2, this is in vitro, to GDC. So they hoped that when they exposed this inhibitor, this treatment, that it would slow the proliferation and stop the cell growth. Okay, and so this is, I'll just point. So the dotted lines are the resistance strands. So they were harder to treat with this inhibitor. But the parental had no, the parental didn't have any mutations that would make it harder. So what this is showing is that no matter the dosage, both the resistant cell lines and the parental cell line were sensitive to the treatment and responded to the treatment.
In vitro.
In vitro. Yeah, this is in vitro still. Any questions? So, because this showed promise in, it showed promise in vivo because it worked in vitro, so they decided to put it into mice. So here they transplanted the TL cell line cells into the mice. And the way that they did it had a few advantages. So the first one was that they could track any resistant development within the cells. And the second one was if the mice had died, they could take the cells out and put them into new mice. Does that make sense? Okay. So they were given, first given GDC, what they were given in the first, what they were given in vitro. So we're just looking at the blue lines. So the black is the control. So in vitro, they were all sensitive. They all responded to the treatment. But as you can see here, the blue, this type of TL did not respond to the treatment. And the difference between this TL and this one, the wild type and the G12D, is that the G12D is more like the leukemia that's in humans. Yes.
So when a line hits the bottom closer to the left side, like the black line is the one that where the survival was the least, right?
Excuse me? What?
The
Okay,
black
so
line.
the
Where's-
black line. So it's the control, and that means that this is what would happen if they kind of didn't get treatment. So this shows that the wild type, it extended their survival time a little bit, but here it didn't at all. It was like the same. So next they decided to test a MEK inhibitor with the PI3K inhibitor. So what that would do is that would still continue to stop proliferation. And in both, now we're looking at the red line, both TLs they both responded to the treatment. And so this is just the dosage if anyone had questions about what they gave mice.
So the graphs A and B up there are the percent, when they say percent survival, even percent survival of the mice, not the tumor cells, right?
Of the mice. So what you see here though is that all of the mice died. At the end of their treatment, they all died. So what that shows is that something was still going on inside of the mice that made them, the cells continue to proliferate, but it just slowed the cells. Does that make sense? Yeah.
And so the red line isn't important to what we're talking about here as well, or is that is the red line like the MEK in?
Okay.
Okay.
The red line is the MEK inhibitor
Okay.
and the PI3K inhibitor. So it is important that no matter what the treatment was, they still became resistant to this inhibition.
Mm-hmm.
Yeah?
So the idea is that the cancer cells start using a different pathway
Yes.
when they're inhibited?
Yeah. So, so the next step for them was to retransplant the TL cells into a new round of mice. So, so they only transplanted the cells that responded to the GDC and to that first responded to either the single treatment or the cocktail treatment, which was both inhibitors. And what they noticed was that none of the treatments responded in vivo. So even if it worked originally, now in the new mice it's not working anymore. The cells continue to proliferate. Any questions? Yeah? Yeah.
So you said at the beginning one of the advantages was that they could take the cells out of one set of mice and then put them in another.
Yes.
Were those cells that they put in the old ones or new ones?
This is so what they're doing here is they're taking the old cells of the mice that had died and putting them into new mice. Yeah?
How is it an advantage if they're still dying?
Because they can test what's happening that's making them still die. Why aren't they responding to the treatment this time?
Good question.
Yeah?
What's the difference between the GDC alone and the GDC plus the PD901?
So they're two different inhibitors, and they target two different things, but together it kind of double inhibits the whole proliferation process. Yeah?
Is there a reason they're not testing with 8901?
They did actually, and it didn't really do much. I kind of just left it out. Anything else? Okay. So what they wanted to test was why they weren't responding the second time around. So as you can see here, this is the parental strand. So this is before it's been mutagenized before it's become resistant. So in these, and these would be the resistant cells. So CE is compound E, which is a Notch1 inhibitor. And Notch1, as I said earlier, has to do with, it has to do with signaling. So it regulates the signaling between adjacent cells. So here you see that when it's inhibited, that it slows proliferation. So that means that the cells are relying on Notch1 to signal the proliferation signaling. Any questions? Yeah.
So the dotted line is the one where Notch1 is inhibited.
Here?
Yeah.
Yeah. Well, Notch1, the inhibitor is being used. But as you see here in the resistant strands, something's going on that's making the resistant strands not respond to Notch1 inhibition. So that means that the resistant cells have found a way to reroute their pathway and still proliferate without using Notch1. So this is what they noticed was that here, this is in the parental, so once again it's the non-mutagenized, and this is just another name for Notch, just think about it as Notch. It signals to PI3K, which will promote cell survival and proliferation. But here, Notch isn't really being activated, and PI3K has found a way to continue to make the cells proliferate even without using Notch. So what the researchers did, and there wasn't a good graph on how they did it, but they gave the cells a Notch1 activation treatment, and they noticed that when you activated Notch1 and treated the cancer cells, that it resensitized, or they were now responding again to their original treatment. Any questions? Yeah?
So would you kind of have to keep giving Notch1 to make the treatment effective?
Yeah, you would still have to continue to activate Notch1. Yeah?
Were the mice all still like dying, even though they were responding?
Yeah.
But not as quickly.
Yeah.
So like this would be like a prolong of like life instead of curing the cancer that they have. So it just gives them like longer time to live.
Yes.
Okay.
Okay, so conclusion. So either the one inhibitor alone or the cocktail treatment slows proliferation in these advanced stage T-ALS. And then researchers then found that the cells were becoming resistant because there was a low activation in Notch1. And the enforcement of the activation in Notch1 can help resensitize the cells to their original treatment. So what's next? This is the first example of treatment in vivo that targets resistant cells that don't use a major cancer pathway. Does that make sense to everyone? Okay. And then, so half the battle of finding ways to treat cancer is being able to test it in mice, and you have to be able to have the mice cancer act just like a human cancer. So they were able to have this mice cancer act just like resistant T-all, which can help them find further treatments for T-all and for this resistant leukemia. That's it. Yeah, any questions? Yeah?
You said they were trying to treatment in late, advanced TL.
Yes.
Did you also try it in less advanced TL to see if it might actually help them more?
No. Okay. Yeah?
Did the researcher, or did the paper say anything about the researchers doing any more research about the other pathway that's not the Notch one, like the other one?
The PI3K?
Yeah, the other pathway that PI3K uses.
So, this one here. So, what they found is even though they continue, sorry. So, even though they tried to inhibit PI3K with the cocktail treatment or the single treatment alone, it didn't affect the PI3K activation. So, does that answer your question? So if they did try to just target the PI3K pathway alone in the resistant cells, but it was not working because there was something wrong with the notch. Does that answer your question? Okay. Cool. Okay.
You said there was another pathway that was used for the cancer, for the cancer cells to be signaled, they wouldn't respond to Notch1. But didn't you say at some point in your presentation that they used another sort of, not Notch1, but another sort of signal regulator in cancer cells?
No, this is the only signaling regulation pathway. But both of these involve cell growth. Is that what you're talking about? Because when you inhibit one of these, it's going to stop proliferation. If you inhibit one of this, it's supposed to stop proliferation. Supposed to. And it's like a double knockout kind of thing.
I was wondering because I was thinking that if you could maybe block another pathway, that if there's another pathway that's found in the cancer cells that's not in itself or in non-cancer cells, then maybe you could block that.
Sorry, didn't say it in the paper. Yeah?
Why would they choose to look at Notch1?
Because they knew that, I didn't really say, but I think that they knew that there was something going on with Notch1 because there was something was being rerouted. Something was being rerouted. I don't know exactly. Yeah?
Was this research only on ALL or were there other types of leukemia?
This was the this is the only type T-all. It's yeah. Any other questions? No? I can't see if